Alright, so what we're going to do in this video is I am going to either show you a graph like in this example, or in the next examples I'm going to give you the properties of that graph, and we're going to write that function. I'm going to start with this one because I think it's a little easier. Now, where I always like to start with when I'm writing an equation, remember we're seeing the words asymptote. When we see the words asymptote, that means that we have a rational function. F of x is going to equal some kind of fraction. Oh, by the way, if you didn't notice, please change your horizontal asymptote to y equals -1, not y equals 0. I want to start with the term vertical asymptote. Vertical asymptotes come from the denominator. So we know that when x is 1, the denominator is 0. So we know when x is 1, the denominator is 0. So what would the denominator be to make this x equals 1? Well, and that's going to be x minus 1, because 1 minus 1 is 0. We have an x-intercept at 3, 0. X-intercepts come from the numerator. Let me change up. There's my highlighter. So x-intercepts are part of the numerator. So we know x equals 3 when y is 0. So if we solve this, we're going to go ahead and get x minus 3 equals 0. So we know the numerator needs to be x minus 3. We have a horizontal asymptote at y equals -1. Now, when we've got a horizontal asymptote, what this means is the numerator and the denominator have the same degree, and when I write the coefficients as a fraction, that's going to be a -1. Well, what we're noticing is in the denominator we have x minus 1. On the top we have x minus 3. Right now the x's have the same degrees. But I need this ratio to be a -1. That means I am going to put a -1 in front of my x minus 3. Boom, get that in blue right there. Boom, boom. And then I could just double check that my y-intercept is actually at -3. So if all of my x's are 0, 0 minus 3, that's going to be -3. 0 minus 1, that's a -3. So why did that not work out? Oh, I'm sorry. 0. Yeah, so 0. Alrighty, sorry about that. I had to take a minute and look back at what I had done wrong. What I did wrong is, there we go. There we go. That's better. Now the -3 for the x-intercept. Perfect. There we go. And then, yep, I am digging it. Much better. Much better. Boom. And then we can just double check with our y-intercept. So 0 minus 3 is -3 times -1. +3. +3 over -1 is our -3. Boom. Easy. So when we're looking at this one, now I want to do this one second because it's giving us the graph and not the characteristics. But the idea is the same. So what we notice here is we have a vertical asymptote when x equals 4. That means in the denominator, I am going to need an x minus 4. And that came from our vertical asymptote. Another thing I see right here is this hole. This hole is at -4. What that means for us is we are going to have a factor that crosses out that when I put in -4 in for x, we get a 0. So those x plus 4s came from that hole. And we notice that they're going to cross out, and we're going to be left with this graph. What this graph is showing me is that we have a horizontal asymptote. Right here, we are looking at a horizontal asymptote at y equals 1. So when we are looking at this, so this horizontal asymptote of y equals 1 lets me know that the coefficient of x and x need to be the same, and they need to have a ratio of 1, which they do. Now, how did I get this x plus 5? Well, it actually shouldn't be x plus 5. It should be, I made a mistake when I wrote it down, it should be x minus 5. And it's minus 5 because of my x-intercept right there. So, because we care about it from the numerator, the parts in green cancel out, leaving me, so what will give me a 5 x minus, when does x equal 5? Well, when I get an x minus 5. And if you graph this, we can see that it works, because these two are going to cross out. That's why we have the hole. They're going to cancel. And then we have we have the same degree for these two x's, and their coefficient is, their ratio of the coefficients is 1. Alrighty, so I know that was a bit convoluted probably for you, but if you got any questions, let me know when we get into class, and I'll be glad to help you.